Hi everyone, I'm sorry I couldn't be in class today. The substitute should have given you the Unit 6 review, and you should have worked on that on your own before coming to this video. But what I'm here to do is just to make sure that there's no confusion or questions about this, because you still will be having your exam tomorrow on the 28th, that I go over these things so that you can make sure if there's any questions they get rectified. So I'm going to go through question by question. That means if you don't have any concerns about the first few problems, you might have to scrub through the video and find when we're talking about the one you want to look at. Okay, so for question 1 here on my answer key, you can see that what I did is, because it asked for what's the x coordinate of the solution, I saw that the y's were lined up for elimination method. I canceled them out with one another, and that let me add them together, but via that cancellation, leaving the x's as 3x and the other piece as 21. So if 3x is 21, we divide by 3 to get 7. Obviously, if this question was altered a little bit and it asked for you to solve for the y coordinate instead, we would have had to do some work, such as multiplying this bottom equation by -2, and then we could have added them together to solve for the y instead. But this one was generated for you nicely to figure it out right away. Number 2 says that we have a graph of a line there. Okay, and then it wanted to know if a system was made so it was comprised of that line that's already there and another line, what would be the following y coordinate for the solution. And so what we would be able to do is basically graph this line. So you can see I have a series of dots on the graph, and they just came from the fact that I would be able to make a table of values for these. So if I plug in a input of 0, I would get an output of 6. If I plug in an input of 1, I would get an output of 4, and so on. So I continued making that table, and I transferred them into points, and eventually we can see, because of the pattern, I have this circled location on the graph. I have 3, 0, and that's where it ended up meeting. Because again, it asked for only one part of the solution, the y coordinate specifically of the solution. In this case, it is 0, choice 1. Okay. So, number 3, which of the following equations would not have a solution that is the same as the solution to the system below? So we talked about a whole bunch of different ways that sometimes systems get manipulated, and that would be via either adding equations together, subtracting them from each other, or maybe even multiplying to manipulate them. So what you can see is I've done a couple of things on the side here, and I want to explain what they are because there's a lot going on. The first thing I did is isolated right here, and that's when I just added these two equations from the system together. And that gets me a different equation. If I add them together, it got me 2x plus 6y equals 8. That means 2x plus 6y equals 8 will have the same solution, so it's not that one. I then took the two equations that we were pre-printed with, and I went ahead and I multiplied them by something. I multiplied the top by 3, the bottom by 2, and so if I multiply the top one by 3, I get 12x plus 3y equals 21, one of our literal solutions there. And then I get, for the bottom one, negative 4x plus 10y equals 2. And that is similar, but not exactly the same as number 3. It looks like whatever choice that was created from only multiplied 2 by the left side and forgot to do it on the right side. So it looks like that's going to be my answer. But I have one more section of work to look at here for you. And it's when I took the two equations from up top and I actually tried to solve them as a system. So down here you can see that I tried solving the system by eliminating the x variable, and that got me the 11y equals 9. And so that's why that ends up also being something that would fit with the system and have the same solution as it. So that's choice 3 overall for that question. All right, if x equals 2 is a solution to the system below, then what must be the value of b? So all I did is I took the equation that we had the most information for, put in the x value of 2, figured out y had to be 18. I then go back and I plug in not only the x value this time, but also the y. And so I put in for those, solved, and was able to find the b value. For number 5, it says we have a graph of these down below, and it asks for the negative solution to this equation. Notice that equation is written in function notation, and so it only has the variable x within it. So one of the negative solutions, so that's why you can see on the left side of the graph I have it circled and pointed out with this arrow here going down there. And it looks like that's around the spot -5, 3. It's not perfect, but it's around there. All right, but what I said before needs to be addressed. This is written in function notation, and so x is the variable of that, would make those two things equal, and therefore it's only the x coordinate I'm caring about right now. So I focus on the fact that x is about -5, and choice 1 is our best estimate for that. Okay. Number 6 should be straightforward. I used elimination method by multiplying the bottom by -2, and then I added them together. You absolutely could have multiplied by +2 and subtracted the two equations, but in both of those situations, they help me solve for the value of specifically y. Okay. It wanted to know for number 7, when do these two things intersect? This is an example that would be more beneficial using substitution property, because x minus 8 can get substituted in for that y value, and that's the work that you see printed on the page. So I made them set equal to each other, was able to solve for the x value being 6, and because it was a multiple choice question, I already was able to find my answer. There's only one of them that had x as 6. And it is an almost identical situation in question number 8. Once again, set them equal to each other and solve. X equals 2. There was only one of them there. So 7 and 8 are very, very similar. Okay, and 9, in my opinion, is very similar to the one we had before, so I don't have to describe that again. If you have any questions about number 9, let's just go back. That was number 4, that was the same thing as. So number 9 had an answer of choice 4. If you need to see how to do the work for that one, go and check out question number 4. They were the same type of problem. Okay. Now this one's similar to ones that we just talked about, but because it's a little bit of a different ordering here, I might as well mention that you can still do substitutions when it's not an entire side you substitute for. For example, here I'm substituting in for this plus y in the middle of a problem. So x plus y equals -3. Well, I kind of just replaced the plus y with that entire binomial, and I was able to then combine like terms and solve to get x equals -2, choice 1. Okay. Number 11 is very similar to another problem that we did previously, so you can go back and look at that problem that had one line pre-printed and another line given to you. So you can see I used a table of values to generate points, and I found out where they would cross. Okay. Number 12 says the point 2, 5 is a solution to the system of equations below. Which of the following equations would not be a solution to? So it's very similar to another question we did before, but they actually gave us the solution as a coordinate this time, which means we could just substitute into all of the answer choices and see which ones work. So like before, you could take this system, manipulate it, and figure out how more of those equations are getting made. But because we have a solution this time, we can just plug in and see which one doesn't work. So you can see I took choice 3, I pulled it out, and when I rewrote it here, I substituted in the answer 2, 5, and it does not check. So that one gave us a little bit of extra information, so there was a quicker / alternate way to do that. All right, number 13 ends up that this one is just an elimination, and the y's were set up to eliminate automatically for you, so that one goes relatively quickly. Number 14, a little bit more work because that was also set up for elimination style. However, you had to do an extra step to manipulate first and then get something to cancel out. So I did that by multiplying by -2 right here. All right, number 15 can be a little let statement that will help you out. I let x equal the first number and y equal the second number for two random integers, and it says their sum is 23 and their positive difference is 13. So I did x plus y is 23 and x minus y is 13, and that let me go ahead and use elimination to say 2x is 36 or x is 18. So I went and I put the 18 back in for one of the equations and found out that the other value was 5. So I know my x is 18, I know my y is 5, and the question says what is the product of these two integers? So it's not as straightforward, it was a little extra step at the end. So the product or multiplication of those two answers, 18 times 5 is 90. All right, and our last multiple choice one here. Okay, we had a similar situation to before, okay, but this time I didn't write it in function notation. This time I just literally wrote it out. And notice if I have these two equations that are graphed for you combined together and I want to know when they're equal, well, now the y value is not listed there anymore. It's the x values I need to take a look for. And so I see where they cross. It was at 1, 2 and 4, -1. And the x values are 1 and 4. Okay, so for the rest of them, they're kind of be like the same thing. For most of these other ones, it's just you have the extra step of doing more work. So I would just emphasize the fact that if you want to look through these, if I skip over them, it's because I already talked about how to do them in a previous multiple choice question. So number 17, we already talked about how to do that, so you can read through my keys. Okay, for number 18, we did talk about that briefly, that you can still do substitution into the middle of an equation. This one, you just have to make sure that when you substitute -2x minus 10 in, you distribute the 5 to this. Make sure you do that distributive property. That's a common mistake, but that can let you use substitution to solve this. Okay. And then here we have 2, 5 as a potential solution for this. So I just put in 2 for x and 5 for y, and that let me make two different situations that I could solve for. The first one, when I plug in x is 2 and y is 5, it lets me find the b immediately. And now I actually can know the y-intercept for this. And then for the other one, I was able to go ahead and find the m value for that one by plugging in 2 and 5 once again. What you might notice so far is that we haven't had any triple systems. I'll talk about that at the end. All right, number 20. So it's just asking you to justify why we can do certain things for the elimination style questions we did, and what we can do is the multiplication property of equality, and what we would do is we would try to multiply the bottom equation by something so that it would cancel out with the top equation in some way. So in this case it was a multiplication of 3 for the multiplication property of equality that happened here. And so if I actually follow up and combine the top equation with the bottom equation, I get this system that then we can go ahead and solve, okay? And so was the value he found for x larger or smaller than 1? Well, we can see x was 3/2 or 1.5 if we complete that solving, so it was larger. Right. Solving graphically, you can see I did do tables because if this was official test practice, you do need to include a table of values for the two equations you're trying to graph. The one with my red markings was already set up for us. I jumped right in, but the one that I did work for in purple right here is all adjusted for y equals at first. So I moved the 5x over by adding it, I divided everything by 2, and then that got me something that had a slope and an intercept to aid me in graphing. But once I had the table, you can see that in the table, -2, 3 is in both of them, and then you also have that as the spot they're crossing on the graph itself. Remember, sometimes these might ask you to check your solution. You would just go put -2 and 3 in respectively for x and y into the original equations to check. Okay, number 22, we have solve the following system by the method of elimination. So I decided to multiply the top by -2 and the bottom by 5. You didn't have to necessarily do that. You could have gone ahead and eliminated the x's first instead of the y's. So maybe I could see someone wanting to multiply the top by -3 and the bottom by 2. That's absolutely fine. I just have one option shown here. All right, and then we have our real life problems that we do sometimes look at when we're modeling things. So go ahead and see that I ended up using the let statement they gave me, that S is number of sodas and P is the number of bags of popcorn. So Ava bought 3 times as many bags of popcorn as sodas, so that's where P equals 3S came from. All right, but then also made sure that we noted that we knew their cost was $4.50 for sodas, $1.50 for popcorn, and that Ava ended up buying a total value of $36. So I know the $1.50 for each popcorn and the $4.50 for each soda had a total 36. So that let me get that. All right, and then I explained how they modeled it in words on the right, but I kind of just did that out loud for you now. But if you would like to see a written sample, you can take a look at what was on the side. And so because this said P equals 3S, I ended up going ahead and replacing the P with 3S as I started to do the work down here for figuring out how much of each item Ava bought. So that let me first figure out that sodas was 4, and since popcorns was 3 times as much, I now know when I plug in 4 for S, that P was 12. So Ava bought 4 sodas and 12 bags of popcorn. All right, and we have very similar situation here, but it ends up that this one lends itself to elimination instead. So they didn't determine a let statement for us ahead of time this time, so that's why you see me writing a let statement down here. Okay, but then you have the information from the corresponding sentences up top coming as equations down below. So 32 pounds of pork and 50 pounds of chicken for $185. And then you have, 8 pounds of pork and 20 pounds of chicken for $65.60. So what I did is I multiplied the bottom one by -4 to get the P value to cancel out of the problem. That left me with -30C equals -$77.40. So when we divide both by -30, we get that chicken must have cost $2.58 per pound. I then used that, put it back in for one of my equations, and solved for the variable P, which was $1.75 per pound. Right. And then number 25 here, the graphs of functions f of x and g of x intersect once. All right, so you can see their table of values were there, and there's a point that happens to be on both tables. So x equals 2 gave the same output. So that's why 2 would be the x value that they match at. And we have more of the same. So I'm not really going to have to explain these ones. These are all practice problems that we've already seen me talk about on this next page with 26, 27, 28, and 29, as well as 30, 31, and 32. Okay, I will have this as instructions for the substitute, but just so that everyone else knows, there are no triple systems on the review. I had a separate sheet for it, but since I'm not there, unfortunately, I can't get that out to you, so I will be posting that online. So you will have an extra sheet of like XYZ triple systems for you to take a look at on Google Classroom. All right, I hope you had a good day.